Today's topic we are going to say about Q, the data structure. So Q is a linear data structure. So Q is an ordered collection of items where an item inserted at one end of the queue is called rear and an existing item is removed at the other end called front. So Q is follows the mechanism first in first out principle, and in Q it has two operations, NQ and DQ. So NQ means inserting the element in the queue and DQ means removing the element from the queue. So for example we can consider the peoples are standing in a queue for getting tickets. So in this, who came first, they will get the ticket first. So that means who comes first, the priority will be given to them. So queue is called queue follow this principle. And here the queue can be implemented in a two ways. So one is using array based implementation and another one is linked list based implementation. So array based implementation is it's a static implementation and linked list is a dynamic implementation. So here in array based implementation, initially we have to fix the queue size, so later we cannot change it. But in linked list we can allocate the size, we can insert the values whenever we want. We can allocate the memory in a dynamic memory in a dynamic way. Using malloc function we can allocate the memory at the runtime. So here you can see the representation of queue. So here the size of the queue is see the first example, the size of the queue is totally 10. So here there is no values, so the front and rear both will pointing to the -1, so it indicates the queue is empty. And in a second example we have stored five values, so the front value is pointing to the zeroth index and the rear value is pointing to the fourth index, that means the last element in the queue. And in another queue, front is pointing to the second position and rear is pointing to the fourth position. Suppose here if we want to insert any new element in this third example, there we have to increase the rear point by 1 and we can insert the new element. So here types of queues. So queue can be categorized into four types: simple queue, circular queue, priority queue, DQ or double-ended queue. So we'll see about these four in one by one. So here in simple queue, there is a two end. One is for insertion and another one is for deletion. So deletion is performed at the front end and insertion is performed at the rear end of the queue. And in circular queue, there is no end because the last node is connected to the first node. So the advantages of the advantages of circular queue over the queue is, in queue, if we are deleting value, we cannot insert the new element into the deleted position. Suppose if our queue contains five size, we are deleting three elements, and the three elements the memory of this the three portions will be wasted, so we cannot insert to the new element. But in circular queue we can utilize the memory, so the memory wastage is reduced in a circular queue. And priority queue, so in priority queue, based on the priority, the values can be inserted and can be deleted. And DQ, it's also double-ended queue. So here the insertion and deletion both will be performed at the rear end, and also the insertion and deletion both will be performed at the front end also. So the both operation is performed in both ends. So operations on queues. So here main operations are NQ and DQ, and Q and is empty size. So queue function, it will create the new queue, and enqueue means adding the new element in the rear end of the queue, and dequeue means remove the front item from the queue, and is empty, this function will check whether the queue is empty or not. And size, it returns the number of items in the queue, how many items are stored in that queue, it will display that value. And here the memory representation of queue, so this is based on array based implementation. So here the front contains the variable front contains the location of the element to be removed, and the pointer variable rear contains the location of the last element inserted. So the always the rear pointing to the last element and the front is always pointing to the first element. The condition, if front equal to null means it indicates the queue is empty. there is no values, so we cannot perform DQ operations. Suppose if the condition equal rear equal to n minus 1, so here the n means number of values, that means consider the q value is 5 means so rear pointing to the fourth index and 5 minus 1 will get 4, so indicates this q is full, so we cannot perform the insertion operation. So this is a queue insertion operation that is called NQ. So the algorithm for NQ is, so we have to check three conditions. The first condition checking for overflow. So in queue there is two exceptional conditions are available. One is overflow and another one is underflow. Overflow means before inserting values we have to check the any space is available in queue or not. So if there is any space we can perform insertion. If not we cannot do it. And underflow also, before deleting the element from the queue we need to perform the underflow operation. So in this example you can see in step 1 we are checking whether the queue is overflow or not. So in this first example the queue size is 5, so the queue is also full, so the condition is rear, so the rear will point into the fourth index. So rear value is 4 equal to n value is 5, so 5 minus 1 4, so 4 equal to 4, the condition gets satisfied, so it will print q is overflow or full. And if we move into the next condition, that means we are checking the empty queue. Suppose if the empty queue means the front and rear will always point into the minus 1, so to insert the element in a empty queue we need to increment rear by 1. So we can increase rear equal to rear plus 1, and the rear point will be increased and we can insert the element. And in a third case, it has the queue has two elements and we have to insert a new element in another position. So we just increase the rear value by 1, and we can and then we can insert the values. Likewise, deletion operation, that is called DQ. So here also we have to perform two cases. So first one is if we need to check the queue is empty or not. So here if queue is empty means the front value always pointing to the minus 1 or null. So if front equal to null, then we need to print the queue is empty or underflow. Or else in second case it has only one element, so if that one element will be deleted, it automatically front and rear both will pointing to the minus 1. So we need to check the condition for this particular one element. So the condition is the front equal to rear. So front one, if there is only one element means front value 0 and rear value 0, so both will be equal means the value deleted, and front is equal to minus 1 and rear is also going to the minus 1, that means null values. So and another third case, it's a normal case. If there is more than one element we increase the front value by 1. So here if we are increasing front is pointing to the 0th index, if we are increasing front value by 1 it pointing to the first index, so the element from the 0th index will be deleted. But in stack, if you want to delete the element we are decrementing the top value by 1, but in queue we need to increment the front value by 1. So this is the main difference between queue and stack. So again we just recall the concepts. So queue is the first in first out mechanism. It has two operations, NQ and DQ. So NQ is performed at the rear end and DQ performed in the front end. So there will be two exceptional conditions. One is overflow and underflow. And overflow is used for overflow we need to check before inserting the element, and underflow we need to check before deleting the element. Okay, so these are all the overall queue concepts.